I gotta tell you, I don't like to toot my horn a whole lot, but I do think that I've done a great job with the project for this week, and I enjoyed it so much, and it's running now, and I love it. I absolutely love it, and I can't wait to get into it and show it to you. And let's start, as always, with the introduction, but very quickly we're going to get to code because that is where it's at this time. So we are going to go deeply into agentic AI. It's such a hot topic. It's something that everyone can't get enough of right now. And so it's worth it that we really go deep and get into it. And we use it as an opportunity to learn more and more about the different components of LLMs that we've worked on already over the last 7.5 weeks. So what we're going to be doing today is talking about agentic workflows, agent frameworks, and then we're going to build an agent framework. We're going to do it today that is able to send push notifications with information about great deals that it finds based on looking at RSS feeds. So it's really putting all the pieces together into a solution. So before we do that, let's just quickly talk about what exactly is agentic AI and agent workflows and all of this. And I think the truthful answer is that it's one of these ambiguous terms that's still emerging and somewhat overused by different groups. So it's used to mean a number of different things. But I think if you take a step back, and I did mention this when we touched on it briefly in a previous week, but if you take a step back, you can think of the hallmarks, the key aspects of agentic AI as having there's 5 pieces to it. And no doubt there are some things that some people will say it's more than this and some people will say it's less than this. But I think that these are the big 5. So first of all, an agentic AI solution is one that is able to take a larger problem, a more complex problem, and divide it down into smaller pieces that can be executed potentially by LLMs and maybe just by normal bits of software. But that ability to take a harder task and break it down is certainly a hallmark of agent solutions. The use of tools, function calling, and structured outputs that we've covered at various points along the way. That's also something that often falls into the remit of an agent solution, is this idea that you're giving an LLM something that's more than just a conversational, here's a prompt, give me back a chat response, but it's something where it's fitting into a tighter construct. We need outputs in this particular JSON format. You can call these different functions to carry out different activities. So that's how that fits into agentic AI. An environment, a framework, environment, different words for it, but some kind of a sandbox in which provides some functionality which all the different agents would be able to take advantage of. The classic example of this would be something like memory. If there's something where all of the agents can share in some bit of information that reflects what's happened in the past or something like that. That would be an agent environment, and just something which allows different agents to call each other in some way. And then typically, and again, this one is an example of something which isn't a must-have. It's not like without this, you don't have an agent solution, but you often see agent solutions having a planning agent, an agent that's responsible for figuring out what tasks to do in what order. And again, I think normally when people talk about this, they're thinking of that planning agent being itself an LLM that's able to take a task and figure out, all right, I want to do this and then this and then this. But it doesn't have to be an LLM. This, if it's a simple problem that just has 5 steps to it or something, then you can just write some Python code that calls those steps, or it can be a JSON configuration file or something. But there's got to be something which is considered your planner to tick this box. Not that it's necessarily required. But perhaps the last one here, which is the one that we've not really done much of to date, is the kind of key. It's perhaps the single criterion that does distinguish between something that's agentic and it is not. And that is autonomy. That is this idea that your agentic AI solution has some kind of a existence that transcends a chat with a human. So we've had memory before because we've had Q&A chats like our RAG solution when we had a chat that talked about the Insurelm company, and obviously it had memory there. And we've had other examples of that too. Even our airline chat had memory. But that's not really considered an autonomous AI because that memory only existed while we had that app running and while the human was interacting with it. It didn't really have any kind of a presence beyond that. So this idea of autonomy is some kind of a sense that this thing has an existence that is more permanent and say is running behind the scenes. Now that might all sound a bit magical, and it's not at all. As you'll see, basically, if you've got a process that's running, that's carrying out some activity that doesn't necessarily need human interaction, that in itself is good enough to say, okay, that sounds like that's an agent solution. So in a nutshell, it's not like there's one super clear definition. And a lot of the times when you're working with an AI solution that is solving a harder problem involving multiple models, involving coordination between them, and in a way that isn't just a prompt and a response, the chat interface that we're so familiar with, anything like that is considered an agentic AI solution. Now, there are a bunch of frameworks which offer agent capabilities. LangChain has a bunch of agent abilities. There's agent tools that you get with Hugging Face. Gradio has something, and there's many others. Some of them are what they call no code. So all you're doing is stitching together different models. Some of them have more code involved, like LangChain's offerings. But one of the points I wanted to make to you is that many of these platforms are putting on abstractions around LLMs, much as LangChain did for RAG when we came across that before. And really, to be building these kinds of agentic AI solutions, you don't need those abstractions. We know how to call LLMs directly, and we can just do it ourselves. We can have LLMs running, and we can send the right information to the right LLM. As now a master of LLM engineering, almost 5% away from being a master of LLM engineering, that's well within your capabilities. So actually for this session, as we get in and build our agentic AI framework, we're just going to be creating these agents, as you already saw, those classes, and have them operating ourselves using Python code. We're going to collaborate them, stitch them together with our own code, which is a great way of doing it, and which also gives you deeper insight into what's happening, and we can actually see what information is being passed between the agents. But of course, you can also use one of the more off-the-shelf more abstraction layer products if you wish. You can look up any of the ones that's available from LangChain or the others, and it might be an interesting exercise to then redo some of what we're doing. It would probably be quite straightforward to do it using one of those off-the-shelf products. But for us, we're going to get to the nitty-gritty. We're actually going to go and build our own little agent framework and have multiple LLMs participate in solving the problem that you know we're setting out to solve, which is scraping for good deals on the internet and messaging us when it finds them. Let's remind ourselves quickly of what that framework looks like. What is our architecture? This is the workflows that we're putting together. We have the 3 models that are running and an ensemble agent that calls them. This is an example of perhaps a bit of a stretch because an ensemble model that calls other models is something that's been around for donkey's years. People haven't called that agentic AI in the past. But since we do have these running as separate classes in their own right that have the same construct and the same ability, as you'll see, to log and to be participating in this framework, it kind of makes sense to think of these as separate agents in their own right. And we could be running them in different Python processes if we wish to. But for simplicity, I just have it just being called directly. But we certainly could do. So I have chosen to suggest that these are separate agents that carry out these 3 different models, and that we have an ensemble agent that calls each of these agents, collaborates with them, and then applies the linear regression weights to give an ensemble of a price of a product. The scanner agent is what we looked at last time. This is an agent. We ended it by calling the scanner agent. It's able to go out, collect feeds, and then call GPT-4o as its way of finding out the good, pithy description of each deal and the price point associated with it. And it collects that together. And you may remember that it had an input memory, which is part of the glue of how we're going to glue everything together. The memory is where we tell it not to surface a deal that it's already surfaced in the past. And what we're going to look at today are these boxes in yellow that bring it all together. We're going to look at a messaging agent, a very simple thing that's going to send push notifications to the phone, which is going to be delightful. A planning agent, which is able to coordinate activities. And it's not going to be an LLM. It's going to be a simple Python script, but it easily could be an LLM. And then the agent framework, which sounds super fancy. It's not fancy in the least. It's just simply something which has all of these agents and which can allow messaging to go on. And that's going to be our agent framework creation today. And then tomorrow we're going to build the user interface that wraps it all together and makes it look fabulous. But I hopefully have motivated you enough to be ready to go. I will see you in Jupyter Lab. And here we are back in the Jupyter Lab for the fast approaching conclusion with a really great project. Super satisfying. Wait till you see. So this time we're going to start by looking at two more of our simple agents, probably the simplest we've got. There's one called the messaging agent, which we will use to be sending messages, and one called the planning agent, which will coordinate activities. And both of these agents are ones which are just Python code. They're not using LLMs, and there's no reason why they can't be beefed up to use LLMs. The messaging agent sends a notification, but of course it could first make a quick call to a frontier model to improve that, to make it something that's juicier and that is relevant to that particular deal. So there's plenty that can be done here. And the planning agent, it's written in code. You could experiment with turning that into an LLM, getting to plan out what happens itself. But we'll at least see them and use them both in a second. And we're going to then afterwards put all of that into our agent framework. But you can imagine, because we've put all of the building blocks together, the final part of having an agent framework is a cinch. It's going to be just very straightforward. So let's start by talking about the messaging agent. This is the agent that's able to send us alerts when it finds a great deal. And originally my plan was to send text messages for this, and I was going to use Twilio, which is a lovely framework that I've used in the past. But there's been a lot of regulations recently that makes it really quite hard to set up a Twilio account to send text messages, even to yourself. Even when you've validated your own phone number and you want to send yourself text messages, you have to fill in a fair bit of paperwork if you're in the US. Now, that might be a lot easier in other countries. It does seem to suggest on the website that it's just a US restriction that makes it so hard. And Twilio has a free plan. Twilio is also free to make WhatsApp messages as well. So you can have it WhatsApp, and I did have it working, WhatsApping myself. But there are some constraints. You just you can only use the free thing if you're using a sandbox, which has some limitations, and you can only do it between certain hours of the day. So it wasn't ideal. So it was okay, and I've kept the code here so you can use it if you wish. But then I discovered something really, as I say, nifty called pushover. There's a few things like pushover, but pushover was the one that I found to be the nicest of the ones I tried. And pushover, it's a simple website where you can go and you set up an account. It's free, and you then download an app. In fact, you don't need to go to the website. The website is pushover.net, not .com. They weren't able to afford .com. It's still up for grabs. But pushover.net is their website, and then there's an app called Pushover, and it's free to set up. At least it's free for up to 10,000 messages, and I think we're not likely for this particular project to get close to that. You can see I've managed to get to 35 messages of my allowance so far. And now the reason this page looks a bit janky is that I've scrolled down because it shows above here my tokens in big letters. And I didn't particularly want to reveal all of my tokens to all of you, or you might be constantly notifying me all through the day. So it's hard not to miss the tokens. As soon as you sign up for your free pushover account, I promise I'm not affiliated, but it seems to be really, really helpful. Once you've signed up, you then take your tokens and you can then easily send push notifications. So you'll end up with two tokens: a pushover user, which is a token that applies to you, and then you have to set up each of your applications, and you just choose one, and I called it Pricer for me, and you can give it a token. Sorry, you can't. You get given a token once you've set up your application for that. And these two things you should add to the .env file. Wonderfully, you can also upload an image associated with your application. And I found an image looking around of a stack of coins. And so I uploaded that because it's great when I get a push notification. There's a little image comes up. And it comes up on my Apple Watch as well. The whole screen turns into this stack of coins. Which is really good fun. So you might want to do the same thing. Find a cute image to go with pushover if you use that. As I say, if you are able to, if you either already have a Twilio account, or if you go there and you see that it is straightforward in whatever country you're joining from, then by all means you can do that instead and get a bona fide SMS text message instead of a push notification. But push notifications are all we need for this. Okay. So I'm going to go straight to this class messaging agent under agents. Messaging agent is one of our agents. Here it is. It's very straightforward. It is basically a wrapper around the Twilio API and around the pushover API. And I've got at the top do text and do push as two constants that you can set. Because if you wish, I didn't want to make it a either or, because you can have both. You can have it text you and push notify you if that is what you desire. So there's an init constructor which sets up the various criteria. If you're doing push notification like me, as I say, you need pushover user and pushover token, and you can always just type it straight in here if you don't want to faff around with .env files. Obviously, then don't push this code. And if you're using Twilio, then you need to have an account SID, an auth token, a Twilio from, which is the number that Twilio will give you, is the number that it's coming from, and then the phone number that you want it to text message to. And so I have these four in my .env file, but I'm not using it because I filled in the paperwork just to have done it, but I haven't yet been granted authorization to send a text message to myself. But hopefully that's going to come one of these days. In the meantime, the push notifications are great. So I've then got two methods here. Message, which is simply a wrapper around the Twilio API, which, as you can see, it's really simple. It's the Twilio client.messages.create, and you say who it's coming from and the text and who it's going to, and that's it. And it will send a text message. I've used it before. It just works. Receiving text messages is pretty easy too. You just have to have an endpoint that gets called, a webhook. But obviously we don't need to do that. The push notification is also very simple. But it doesn't use an API because they're sort of keen to point out, I think, on their website that it's intentional. They just want to keep it as straightforward as possible. They don't even use the requests library in their example code because they wanted to say you don't need to import anything. You can just simply use out of the box Python to send a push notification, and you simply pass in the token, the message. And optionally, you can include a sound. And one of the ones that they suggest as being available is called cash register. And it makes a very pleasing cash register sound when I get the notification, which is great fun. And that's all there is to it. And then there's an alert method here, which based on whether you're texting or pushing, it will construct something to tell you about, and it will then send a message, and it takes an opportunity. So you pass in an opportunity and you'll get a message about that opportunity. You remember opportunity is the object that we looked at down here that has a deal, an estimate, and a discount. All right, but first let's just quickly try it out. I should just be able to create an instance of this, and I should be able to say massive news, and Bing, my phone just went. Now, unfortunately, I have quite aggressive noise filter on my microphone to only bring out voice. So I imagine you didn't hear the cash register. It's, as I say, very pleasing indeed. Luckily, you'll be able to hear it for yourself when you try it out. Yeah, I'm going to have to hear that again just because I love it. There it goes. Yeah, my watch too has come up. It's yeah, very satisfactory indeed. That then is the messaging agent. I will see you next time for the planning agent. Okay, and so now to look at the planning agent that's set up right here. I will take you first of all over to the code so we can have a look at it. I've gone straight to the agents folder, and let's look at planning agent. Here it comes. So as I say, often you'll see that people build planning agents to themselves be LLMs. It's very much like function calling tools. You can say to an LLM, hey, you've got these 5 agents that you can call between. This is the task that's desired. Please now decide what order you want to call which of these agents. And you can perfectly easily imagine a prompt like that. And you could either use function calling for it to select which one it does, or you could simply have it returning JSON or structured output if you prefer, and use that. I think the recommendation would be to use the function calling because you can be so specific about what has what function, but either will work. In our case, though, our workflow is very simple. We know exactly what has to happen in which order. So our planning agent is just Python code, and it's right here. And a nice challenge for you, just because it would be quite satisfying, is to try and turn this into an LLM-based planning agent to give it more sort of autonomy in a sense. Although hopefully it will end up doing exactly the same thing, or something has gone awry. So there's an init, a constructor, which creates the 3 agents that it coordinates with: a scanner, an ensemble, and messaging. You may remember the ensemble itself calls the 3 different models. We could equally easily have had the planning agent do all of that and then send the ensemble agent the pre-calculated numbers. But I thought it was more elegant to have the ensemble agent collaborate itself with the agents that it is ensembling. So that's the constructor. There's then a method run. A run takes a deal and turns it into an opportunity. So if we go back to this class again, you remember this is a deal, which is just a description, a price, and a URL. An opportunity is something which contains a deal, but also has the estimate and what kind of a discount that is. So basically it's a wrapper around a deal which adds in the information about how much we estimate this product is actually worth. And so that becomes the responsibility of the planning agent, to this run method, to turn a deal into an opportunity. Of course, the way it does that is it will first get the product description and it will call ensemble.price. It will get the price. It will then work out the discount and create a new opportunity object and return that. And that brings us to the meat of this of the planning operation. It is plan is the name of the method. It takes memory and it returns optionally a single opportunity. So actually, you might have thought we were going to try and surface multiple opportunities, but we're not. We're only going to come up with one, the single best opportunity. And this is how it's going to work. It is going to first use the scanner. It's going to run a scan, passing in the memory that it receives so that we don't resurface the same thing. And then, assuming we get something back, because you may remember the scanner was able to return none if it wasn't able to find anything. If we get something back, then we turn each of those from being deals into being opportunities by calling this method here. In other words, we estimate it and package it up. We then sort that in order so that the most attractive deal is at the top. We take the best one, and then and this should really be configurable. It's a bad thing when you hard code numbers like that. Maybe I should do that right now. But if the best discount is more than $50, because we're not that interested if it's not going for $50 less than we think it's actually valued in the market. But if it's more than $50, then we alert. We call messenger.alert, the method we were just looking at a moment ago, to send that push notification. And then if that were the case, we return it. So let's just quickly do a little production improvement here. Let's say deal threshold was 50. Back down here again. Self dot deal threshold. And before you mention anything, I know, I saw that. There we go. We've got it in the right place. I'm checking out I spelt it right. I did. And so that's a small productionization improvement that we've made together. You shouldn't hard code numbers in production code. And this number 5 probably shouldn't be hard coded either, and so on. Feel free to make improvements like this as you come up against them, because we can turn this into really robust production ready code. So with that, let's go back to day 4. So we can then call planning agent with a, we have to pass in the collection, the Chroma collection, because it needs to know the database that it's being used against. And that's going to come in from an agent framework. And so we create one of those and then we run it. I already just ran it before recording this because, of course, it takes a few minutes to warm up modal, unfortunately. But it ran and it did indeed return an opportunity and a high efficiency battery, it seems, priced at $400 that it believes should be worth $863 according to our ensemble of different models, including our proprietary LLM deployed on modal. And so it says that that's a $460 discount, which is great. And I did indeed get a deal notification, which I go to the pushover app to bring it up. And I'm sure you take my word for it, but there you can see it. It has prompted me, and you can even see my a little icon of the coins, which I love, the yellow coins, telling me there's a deal alert. And wonderfully, of course, there is the URL in here, the link, and I can tap on that link. And if I tap on the link, it takes me over to the page with that deal on dealnews.com. And that's also another time we're being a good citizen, because the reason that Deal News makes all of this available for people like us to scrape it is because they hope that we will direct traffic back to their site to actually take advantage of the deal. We won't take them somewhere else like Amazon. We'll take them back to theirs, and that's exactly what we do. We bring them back to Deal News so that people can purchase this great deal. So that's wrapping up the planning section. It only remains now for us to talk about an agent framework, and that is going to be the topic of the next video, and I can't wait. I'll see you there. Well, the first thing you're going to notice is that I don't have a notebook open for you, and that's because this time we're just going to be looking at code. No notebooks for this recording, for this video. We are going to look at the actual agent framework itself that we're writing, that we built, that we're going to run it in. And it sounds like something so fancy, but in fact, it's going to be incredibly simple. And it's a reason why I didn't want to use an off-the-shelf kind of package, because I just wanted to show you that there's nothing more than connecting together different LLMs and bits of Python code to carry out a more advanced function. And typically when you talk about these sorts of agent frameworks, what you're looking for is you're looking at something that can handle the database connectivity, in our case to our Chroma RAG data store, memory. So we're going to want some sense of persistent memory that can survive between different chats or different instances. So we'll understand how memory is going to work. And also stuff like logging, I mentioned, is sort of good practice to be able to understand what's happened in your environment. And then there's also going to be some user interface concerns that we're going to want to build a Gradio UI that's going to be able to use this framework. So it's going to have to handle that. But that last one we're going to get to in the next set of series. So for now, we're going to look at our framework. Just before that, a couple of things to point out. First of them, when we looked in our agents folder, we've looked at each of these different classes that represents a different unit of work. And you'll notice that each of them were subclasses of agent. And you may have wondered, what is that? What is this agent that he's subclassing? There must be all sorts of functionality in there. Well, actually, no, there's very little functionality in this superclass. It is actually just an abstract class which is able to log a message. And the way that it logs a message is it does logging.info. I imagine you're familiar. You've used Python logging probably, and so you're pretty familiar that logging.info logs to wherever you set up a logger for. The one thing that I'm doing that's a bit different here is that I'm going to add in the name of the subclass of the agent that's actually sending this log message, and we're going to give each one a color so that we can see which agent is doing what. And for example, if I go back to, or if I go to the specialist agent, you can see that it's given itself a name of specialist agent, and its color is red, so that when it logs, it's going to appear in red. And you can see that you might have noticed that I didn't do logging.info, I did self.log, and that's so that I can call the log message in the superclass. So there's really nothing fancy to this agent superclass. It just meant that we could log consistently. You could equally well have just included that function in the different classes. Nothing particularly special about the agent. All right, one other bit of groundwork to do is to show you this JSON file called memory.json. And it is a simple piece of JSON. And if it didn't exist, then you'll see we'll create it manually. Let's open it with the editor, not with the fancy one, but with the normal editor. And this is what it looks like. It is a list. You can see it's got a list on the outside of it, a list of JSON blobs, and each JSON blob is something which may look familiar to you. Do you recognize what it is? Give you a second. It's, of course, an opportunity object turned into JSON. It's got a deal, which has a product description, price, and URL. And then it has the estimate that's come from the model. And it has a discount, which is quite simply this number minus this number. Oops, that number. It's how much is this being offered at a discount to what we think it's really worth. So this memory has 3 deals that have been surfaced. Now, storing it in a JSON file like this is perhaps not the most industrial strength. If that went into a database, then it's something that could handle multiple of these agent frameworks running. But we only have one agent framework that'll only write to this memory once when it does its work. So that wasn't strictly necessary. But of course, it could go in Chroma easily. We've got a database hanging around already. So you could certainly take that as an exercise if you wish. That would certainly be a good production improvement to make. But anyway, the time has come to look at the actual framework itself, the agent framework. So let's do that right away. And I want to make sure I bring up the right class so that I don't give too much away of what is still to come. Here it is, deal agent framework. Okay, so the agent framework is something which, first of all, it sets up logging. This is something which is standard Python stuff that will make sure that when someone does logging.info, it will get sent to standard out, and it has some structure to it. So this is a sort of standard boilerplate Python stuff to make sure we log properly. And then this is the deal agent framework. It's got coded in it the database, the thing that I accidentally left off a couple of times. So that's coded in here along with the name of the memory file. When it starts up, it will begin logging. It will make a log message itself. It will load the .env. This is something that we, of course, always do in all of our Jupyter notebooks. So this needs to do it now. It will create, or it will access the database. It will read in memory from that JSON file. It will get the products collection, and it will then set the planning agent, initializing it with the collection that it needs to look at. And then it will say, I'm ready. This method here, read memory, does exactly what it says on the tin. You can see I haven't hard-coded the name of the file. Well done me. So it loads this in from JSON. If it doesn't already exist, then it just returns an empty one, which is completely fine, because there's also a function, a method here, write memory, which writes out these opportunities to the memory file. There's a log method here to send a log message with its own agent framework tag. Then there's a run method that actually kicks off the planning agent, and once it gets back a result, it says it calls self.planner.plan. That, of course, that's the big moment. That's when we actually set this thing going. And look, it passes in its memory. It passes in the memory of opportunities that it knows about. So in that goes. And then it logs the result. And if the result wasn't none, remember that the planner might return none if it doesn't find anything new. But if it was a real result, then it adds it to the memory and writes the memory and returns the result. And that is it. This last piece here is coming up in the UI to next time. But for now, that is the end of the framework. So how do we run this framework? Well, we run it from the command line. This is now for reals. This is no longer, this is all Python code. We're outside the Jupyter world and we're using this interface for convenience, really. But you could be using VS Code or something like that. The way to run the terminal is we press the plus button here. We can also do it in Jupyter Lab, and we can open a new terminal like this. This is you can also, of course, be doing this however you like to do it. It could be an Anaconda prompt. Or it could be, you could be using, if you're using a Mac, then you can just bring up a new terminal window. But I am first going to have to activate my Conda environment. So I do Conda activate LLMs, which will mean that, as you're now very familiar, my environment changes from base to LLMs because I'm now in that Anaconda environment. And I really think that's it. I should now be able to say Python deal agent framework, spell it right, .py. And that should really be it. There is one more thing I need to show you before I do that, though. I almost forgot, just as well. It's just this very last 2 lines here. You might have been wondering what's going to happen if I do that, if I don't show you this. So at the very end, we, of course, make it clear that if this is being run from the command line, so that this file is main, then we instantiate, we create a new instance of deal agent framework, and we call this run method that we just looked at. That's the little missing link there, just to explain. Okay, with that, now I should be able to run this. Take a deep breath. Let's do it. A long pause while it thinks, huh? All right, let's see what's going on. The agent framework says it's initializing. The planning agent is initializing. Scanner agent becomes ready. The ensemble agent gets ready. So then it's a bit hard to see this red. The specialist agent, which is connecting to modal, gets ready. And then the frontier model gets ready. It has to load in that sentence transformer. You can see it's happening there. And then the random forest agent gets ready as well. And that's done. The ensemble is ready. The messenger is ready, and everything in blue here, it says agent framework is ready. So it went through instantiating and creating all of our agents and setting them all up. They've loaded their model weights. The single one, the specialist model, has connected to modal, and they have now all prepared themselves for action. Model weights have been read in. And it's kicked off a run. The scanner agent, you can see here, received, it looks, there's an error there. I'll improve that. It's not printing the actual number of results. It's printing, needs an F before it. I will have fixed that before you see it. So the scanner agent is making that call. And now the planning agent is pricing up the deal, and it's now sitting with modal while my machine warms up. But as they say on those cooking shows, if you know what I mean, you have those cooking shows when they put the thing in the oven and they say, and here's the one that I put in earlier, and they pull it out of the oven. I always think that's a devious trick when they do that. But you're going to have to trust me that I did just do this. I just kicked it off a few minutes ago, and it ran over here, and that's where I left it, and it finished up its thing. And you can see that basically for each of the 5 deals that returned, it made a series of calls to all of the different models. You can read through each of this. The ensemble model returns a number. Sorry, we should work back. First of all, the specialist model calculates a number, and then the frontier model calculates a number with the RAG lookup, and then the random forest model, and then the ensemble model, and that goes back to the planning agent. And so you can read through all of this, and at the end of this, it completed, and it sent a push notification, and I did indeed get a push notification about this particular deal that it found, which was a certified refurbished laptop boasting a 13th generation i5, which the estimate was $925 for that, which was a very healthy discount to what it was going for at $560. So there we have it. That was the run of our agent framework running. Yeah, it's incredibly satisfying to see that happening. I absolutely love watching it, and could watch it all day, I have to say. It's hugely enjoyable. Look, I didn't even need to bring that one out of the oven, because the one that we put in the oven is now cooking up. You can see once modal is warmed up, it's quite fast in how it turns around the different things. So it's going through there, it's come up with something, and of course what it's proposing is different to what it proposed a moment ago. And I just got the notification on my phone, and no doubt on my watch. So we just saw the full framework running and me getting the notification, and you can read through this trace and see how each of the agents are collaborating to solve this problem. And so all that remains for this is to make it really autonomous so that it's running all of the time. And while we're doing that, we might as well slap on a great UI, because we know how to use Gradio and we know how good it is. And all of that is what we're going to do tomorrow. But for now, I'm going to let you, of course, enjoy this. I do hope that you're running this a few times, because it's so satisfying. Honestly, I love it. Hope you're finding just as much enjoyment as me. And I will see you for the slides to wrap up the day. I realize my enthusiasm for this project is a bit insane, but I have to tell you that I have been very satisfied with the outcome. It's rare that you come up with a project like this that has so many moving parts and is technically quite complex and has a lot of substance to it, but have such a simple and tangible outcome as our push notification for a good deal. There is something beyond the ka-ching of the notification that really makes this very satisfying indeed. But one point that I wanted to make about it, perhaps more seriously, is to point out that this sort of template that we've got here for solving this problem is something that you can apply to a lot of other similar kinds of business problems and startup ideas and commercial problems that you might even have been thinking about already. I mean, to give you something that comes to mind right away is that when I was looking on Hugging Face for the data for this project, for the Amazon pricing data, I also came across a bunch of data that has company reports, annual reports from companies, and shows how that relates to the change in share price on the day and the few days after the report comes out, which is a very interesting data set. And it occurs to me that whilst this is more of a stretch, it is also obviously a bigger opportunity if you can find a way to crack it. If there's a way to build a proprietary model that's able to look at that and make some prediction about what will happen to the share price as a result of a company's report being published, and you could imagine then having a scanner agent that scans for new company reports being released. And so you can really see the very similar agent workflow that you would adapt for that kind of problem. Now, of course, I will tell you that any trading decisions that you make are entirely at your own risk, and I have nothing to do with them at all. And obviously, no one has yet cracked that problem of being able to build an automated AI system that can do things like read company reports and make trading decisions, robust trading decisions as a result. But it seems like a serious, a very important challenge to take on. And I wanted to point that out because it shows you how similar that is in terms of the bits and pieces of the puzzle that you would look at if you wanted to do that. So that could certainly be a big challenge, if nothing else, just for the interest of seeing what happens and seeing whether you can find signal in that kind of data, and using it as an opportunity to build a similar agent workflow. Okay, anyway, with that, let's move to the last slide of this week, which is of this day, which is to tell you that there is now one day left. There is one final day, week 8, day 5, which will be the conclusion of this course, and you don't want to miss it. Before I tell you what you'll do then, just to remind you, at this point, you can generate code and text with frontier models, with open source models, using Hugging Face, using APIs, with tools, structured outputs, RAG, with assistance from Gradio. You can follow that strategy we went through to solve problems, including curating your data, which is hard and grueling, but perhaps the single most important step. Making your baseline model and fine-tuning a frontier model, and then you can select and train an open source model. And we did it. We beat the frontier when we did that. You can deploy models to production now. You can use Modal to put something up there on the cloud. You can also productionize your code in other ways and prepare it into something that can be run in production environments. And now you can build agentic workflows with planning, memory, databases, and multiple agents working together to take a complex task and break it down. And so that brings us to preparing for tomorrow. Tomorrow, of course, we're going to be building a user interface, which is going to be glorious because it's in Gradio. We'll also be looking at the fact that today, when we ran that workflow, you'll notice that it ran and then it completed. So it's not really autonomous, and that it doesn't keep running and have, it still relies on the human to press it each time. So we need to fix that, of course. So we will do both of those things tomorrow. And once they are done, that will leave you in a position where you will have mastered AI and LLM engineering. And I can't wait for that point. I hope that you're both excited and proud, and I will see you there.